Building a B2B SaaS brings unforgiving constraints. You need zero-leak data isolation between corporate tenants, and you have to render data-heavy, highly reactive dashboards. Faced with these demands, the industry reflex is often to reach for distributed microservices on day one to solve theoretical scaling fears. This introduces massive DevOps overhead. You suddenly have to manage service meshes, distributed Saga transactions, and network latency between domains before you even have a product. The alternative is usually a poorly planned monolith. Because boundaries aren't enforced, a developer updating a billing feature can accidentally expose another company's user profiles. Enterprise-grade scalability and security do not require physical microservices at the start. They require strict, mathematically enforced boundaries. This brings us to the Arab Enterprise Kit, or AEK. It relies on a strictly scoped modular monolith paired with a decoupled single-page application. This diagram shows an isometric server stack. The backend is a single application, but it isolates packages like security, billing, and chatbots. They communicate exclusively through standard internal interfaces, giving you microservice-like boundaries with monolith-like deployment speed. To prove the security of this architecture, we will trace the exact lifecycle of a single, routine HTTP request. Understanding the mechanical flow of one simple action, like creating a new employee, reveals the entire defense in-depth strategy of the system. The request begins when an HR manager clicks Save Employee on a dense, data-heavy dashboard. Legacy Angular applications relied on a library called Zone.js. Zone.js is an execution context that monkey patches browser APIs to constantly check the entire document object model tree for any data changes, which causes sluggish scrolling on massive dashboards. We bypass Zone.js entirely by upgrading to Angular 21 and using its Signals API. Signals are reactive wrappers around values that notify the framework exactly which variable changed, providing granular, synchronous state updates. Deploying this dense UI to the Middle East and North Africa introduces a secondary challenge. The platform must support both English left-to-right and Arabic right-to-left layouts, without the maintenance burden of duplicate CSS style sheets. The solution is Tailwind logical CSS properties. Instead of hard-coding a left margin, we use logical classes like psess4 for padding start. This dynamically flips the layout direction based solely on the HTML dir attribute. A zoneless, logically styled frontend immediately captures user intent and formats it flawlessly, setting up a clean data payload for the backend. This flowchart maps the request lifecycle across our architecture. As the data payload leaves the Angular client, we have to authenticate it. Traditional stateful session cookies store user data in the server's memory, which creates severe bottlenecks if you try to horizontally scale your API across multiple nodes. Instead, the Angular frontend uses an HTTP interceptor to automatically catch the outgoing request. The interceptor injects a JSON web token, signed mathematically with an HMAC SHA-256 secret, alongside a specific X-tenant ID header. This stateless authentication is the critical mechanism that allows the backend to scale infinitely without relying on distributed memory caches. The request now hits the Spring Boot backend. Before it ever reaches business logic, a once-per-request filter intercepts the traffic. The filter mathematically verifies the JWT signature. It then extracts the user's role-based access control privileges and loads them into a security context holder. Simultaneously, the filter extracts the X-tenant ID header and immediately stores it in a ThreadLocal context holder. ThreadLocal is a Java construct that allows variables to be read and written only by the specific thread executing the current request. There is a massive architectural danger here. Tomcat servers recycle threads for performance. If a worker thread processes company A's data and returns to the pool, it can be assigned to company B while still contaminated with company A's ID. We prevent this by dropping a finally block at the end of the request that completely wipes the thread's memory. Meticulously sanitizing thread context is the non-negotiable prerequisite for safely operating a multi-tenant backend. The request passes into the service layer and triggers a database save. We utilize a single schema database where all tenants share the same tables, distinguished only by a tenant ID column. This drastically reduces infrastructure costs and simplifies connection pooling, but introduces severe isolation risks. Isolation is guaranteed without relying on developers to remember to filter their queries. An aspect-oriented programming interceptor unwraps the Hibernate session the moment a database transaction begins. Hibernate intercepts the query and mathematically mutates the raw SQL string before it hits PostgreSQL, forcing the database to only interact with the exact tenant ID stored in our ThreadLocal context. This raises a macro-level risk. How do you safely update this massive, shared schema across thousands of tenants without downtime? Non-deterministic tools like Hibernate Auto DDL are strictly disabled. Instead, we use Liquibase, treating the database structure as version-controlled code. On application startup, Liquibase calculates an MD5 checksum for every change set. An MD5 checksum is a 128-bit hash value that acts as a digital fingerprint for a file. If a developer accidentally alters a previously executed migration, the checksum fails, the mismatch is detected, and the application gracefully refuses to boot. True zero-leak architecture is achieved only when the framework, not the individual developer, unconditionally enforces both SQL parameters and schema integrity. Securing standard read and write operations is nearly the baseline. Enterprise software requires volatile, third-party processing. We handle Stripe billing subscriptions through asynchronous webhooks. To prevent malicious spoofing, the backend cryptographically verifies the signature header hash against the raw request body and processes the payload with strict idempotency. Idempotency guarantees that if Stripe accidentally sends the exact same payment event twice due to a network stutter, the system only upgrades the account once. Corporate clients also demand intelligence, but enterprise privacy requirements dictate a zero data leak policy. You cannot send sensitive financial or healthcare data to public APIs like OpenAI. We integrate the Spring AI framework with local Llama containers deployed directly inside a virtual private cloud. This keeps large language model inference entirely in-house. Finally, the Middle East market requires formal bilingual PDF documents. Standard HTML to PDF converters frequently butcher Arabic typography. We use Jasper reports to explicitly embed raw TrueType font binaries directly into the PDF metadata, guaranteeing flawless Arabic cursive rendering on any device. Because the modular monolith strictly quarantines context and data at its core, it can safely orchestrate these heavy, volatile enterprise extensions without risking systemic collapse. From Angular signals capturing intent in the browser, to stateless JSON web tokens crossing the network, to ThreadLocal context holders, and finally down to Hibernate's mathematical query isolation, the entire lifecycle is engineered for security. Robust scalability and multi-tenant isolation do not require adopting 50 distributed microservices on day one. The ultimate enterprise architecture is a disciplined, deeply understood modular monolith where boundaries are enforced by architecture, not by accident.